Today we're going to study how to graph linear inequalities in one variable. First, let us see some symbols for inequalities. The first is the symbol more than. The second is the symbol less than. Now, the third symbol is more than or equal to. The fourth symbol is less than or equal to. Let us have some examples, and these are true statements. 7 is greater than 5. Next, 2 is less than 3. Next, 7 is greater or equal to 5. Next, 2 is less than or equal to 3. Next, 7 is greater or equal to 7. Next, 2 is less than or equal to 2. Let us note that on the number line, the lower number is placed on the left side of the higher number. Let's have an example. We have the number 5 and number 7. We know that 5 is lower and the 7 is higher. So the 7 is placed on the right and the 5 is on the left. Now, let us learn how to graph linear inequalities in one variable. We will follow two steps. Step 1, draw the number line and look for the reference number. Step 2, identify the solution set based on the given inequality. Let us have example 1. Graph and give the interval notation. We have here x is greater than 3. It means we want to identify all numbers that are greater than 3. Take note, it is not equal to 3. Some examples are 3.001, another is 3.2, next is 4, another example is 6, another example is 10, another is 200, so on and so forth. So to write this on the number line, we're going to first identify the reference number. Our reference number here is the number 3, and we can see that the number 3 is here. So all numbers that are greater than 3 are found on the right side of the number line after the 3. But take note that since number 3 is not part of the solution, we are going to put a hole on top of the number 3. Next, for the interval notation, we're going to put the solution set, and we're going to write the endpoints of the solution set. Take note, the first number that we're going to write is the lowest. So in here, the number 3 is written here, but since the numbers greater than 3 are unlimited, so we put this symbol infinity. Now, we're going to use the parentheses, and that means the number 3 is not part of the solution. Also, every time we have infinity, we will always use a parenthesis. Let us have example 2. Graph and give the interval notation of x less than or equal to 1. Let us give examples. The first example is the number 1 itself. Because of the symbol less than or equal, the number 1 is part of the solution. Next example is 0.5, then 0, then -3. Another example, -11, also -150, so on and so forth. So on the number line, first let us locate the reference number, and that is the 1. The number 1 is here, and all numbers that are less than 1 are those numbers that are going to the left side. So we draw a blue array here going to the left side, and this is going to -infinity. Take note also that since 1 is part of the solution, we put a solid dot on top of the 1. So for the interval notation, again we're going to write the solution set. Let us start from the lowest number up to the highest number of the solution set. So on the left side, it is coming from the -infinity. That's why it is used here. And with the 1 as the highest number on the set, it is now placed here. Now, we use square bracket after the 1, which means 1 is part of the solution. This is the general form of inequalities with its corresponding number lines and corresponding interval notation. We have here 4 types. This is the first, this is the second, the third, and the fourth. On the first, we have here x is greater than a number a. So on the number line, we identified first the a, and then all numbers that are greater than a are going to the right side of the number line after the a. And for the interval notation, we put first the a, comma, and infinity, and then the left parenthesis because a is not part of the solution, and we also put parenthesis after the infinity. We take note that all the time for the infinity, we always use a parenthesis. For the second type is the x greater or equal to a. Again, we identify our reference number a, and then all numbers greater or equal to a are those numbers that are on the right after the a, and this is again unlimited. Take note that a is part of the solution, so we put a solid dot on the a. For the interval notation, we copy the a and the infinity, and we use the square bracket. For the a, it means a is part of the solution, and after the infinity, we put the parenthesis, because for the infinity, again, we always use parentheses. The third form is x is less than a. The reference number a is here, and then all numbers that are less than a are those numbers that are on the left of a. And this is going to -infinity. Lowest number, and this is never ending, so we put the -infinity. Again, we put the parenthesis every time there is infinity involved, comma, and the a follows with this close parenthesis, which means the a is not part of the solution. The fourth type is x is less than or equal to a. This time, the a is part of the solution. and all the numbers that are less than a. So it is going to the left side. And on top of a, we use the solid dot. For the interval notation, we put parentheses every time there is infinity, and this is negative infinity, comma, and a with a square bracket. And that means the a is part of the solution. Let us have example 3. Graph and give the interval notation of this x greater or equal to negative 3. First, let us draw our number line. Let us identify our reference number, and that is the negative 3. So it is here. So all numbers that are greater than negative 3, so those numbers that are on the right, going to positive infinity. But because of the greater or equal sign, the negative 3 is part of the solution. We put a solid dot on top of the negative 3. So for the interval notation, we use the square bracket and then the negative 3, because the square bracket denotes that this negative 3 is part of the solution, followed by comma, and all numbers that are going to the positive infinity, we use infinity and the close parenthesis, because every time there is infinity, parenthesis is used. Today we're going to study double inequality. We say that when the end numbers of an interval on the number line is fixed, double inequality occurs. Let us see some cases of double inequality, and this is the first case. We read this as a is less than x and x is less than b. Take note that the values are between a and b, and a is less than b. If we're going to put this on the number line, first let us draw a number line and put the numbers a and b on it. Make sure that the lower number a is on the left side and the bigger number b will be on the right. And then we're going to connect these two numbers with a line segment, and since a and b are not part of the solution, we put a hole on the a and b. And then for the interval notation, we're going to first write the end numbers, the a and the b, and use the parentheses. That means the a and the b are not part of the solution. Let's have example. Negative 3 is less than x and x is less than 4. On the number line, we will put the negative 3 here on the left side and the number 4 on the right. Then we're going to connect the two numbers with a line segment, and on the exact numbers negative 3 and 4 respectively, we're going to put these holes. And for our interval notation, we have the negative 3 and 4 as the end numbers, and we will use the parentheses on both sides. That means the numbers negative 3 and 4 are not part of the solution set. Let's have case 2. A is less than or equal to x and x is less than b. On the number line, we put the numbers a and b respectively, making sure that the a is on the left side because that is a lower number and the bigger number is on the right. Then we will connect the two numbers. Since A is part of the solution, we're going to have a solid dot, while for the B, which is not part of the solution set, we're going to put a hole. For the interval notation, we wrote again the A and the B. For the A, we use the square bracket because A is part of the solution. And the B, we put parentheses. That means B is not part of the solution. Example, -6 is less than or equal to x, and x is less than -1. On the number line, the -6 is on the left side, the -1 is on the right. Then we will connect the two numbers, but the -6 is part of the solution. We put the solid dot. For the -1, we put a hole because -1 is not part of the solution. For the interval notation, we put the -6 and -1, the end numbers of the solution set. Then we use the square bracket for the -6 because the -6 is part of the solution. We put the parentheses on the -1 because it is not part of the solution. Case 3, A is less than x and x is less than or equal to b. On the number line, the two numbers are here, A and B, making sure that A is on the left side, being the lower number. And then we're going to connect the two numbers. For the A, we put a hole because it is not part of the solution set. For the B, there is a solid dot because B is part of the solution set. For the interval notation, we put again the end numbers, the A and B. For the A, we use parentheses because A is not part of the solution set. For the B, we use the square bracket, which means B is part of the solution set. Example, on the number line, the -2 is on the left side and the 5 is on the right. Then we will connect the two numbers. For the -2, we put a hole because it's not part of the solution set. For the 5, we put the solid dot because 5 is part of the solution set. And for the interval notation, we put the end numbers of the solution set, the -2 and the 5. And for the -2, we put the parentheses because the -2 is not part of the solution set, while square bracket for the 5 because 5 is part of the solution set. Case 4, when we have A is less than or equal to x and x is less than or equal to b. On the number line, we put the A and B, making sure that A is on the left side, being the lower number. And then we will connect the two numbers. Numbers of the solution set are between the A and the B. Now, we put a solid dot on the A because A is part of the solution set, and also with the B. We put a solid dot, being the B as part of the solution set. For the interval notation, we use the square bracket for both sides because the A and the B are both parts of the solution set. Example, -2 is less than or equal to x and x is less than or equal to 5. On the number line, we have the -2 on the left side and 5 on the right. Then we will connect the two numbers. We use the solid dots for both the -2 and the 5. All the members of the solution set are in between this -2 and 5, including the two numbers. For our interval notation, we wrote here the endpoints or the end numbers, and then the square brackets for both sides. Today we're going to solve linear inequalities. Let us define first linear inequality. A linear inequality in one variable is an inequality that can be written in one of the following forms, where a, b, and c are real numbers and a is not equal to 0. First is ax plus b is less than c. Second, ax plus b is less than or equal to c. Third, ax plus b is more than c. And ax plus b is more than or equal to c. Let us have now the addition and subtraction property of inequality. For any numbers a, b, and c, if I have an inequality here that a is less than b, then a plus c is less than b plus c. Also, a minus c is less than b minus c. In words, we can add or subtract the same quantity or number from both sides of an inequality and still keep the inequality. It means the sign of inequality remains the same. Let's go now to multiplication and division property of inequality. For any numbers a, b, and c, first we will multiply or divide by a positive number. If I have an inequality a is less than b, and given that c is greater than 0, this expression here means c is a positive number. Then ac is less than bc, or we multiply c to each side of the inequality, and a over c is less than b over c, or dividing both sides of the inequality by the positive number c. Also, if I have the inequality a is greater than b, and again c is positive, then ac is greater than bc, and a over c is greater than b over c. In words, when we multiply or divide the inequality by a positive number, the inequality sign stays the same. Let us now multiply or divide by a negative number. If I have an inequality a is less than b and c is less than 0, this expression means c is a negative number. Then ac is greater than bc, and a over c is greater than b over c. Take note of the inequality sign. From less than, it becomes greater than. This will always happen when we multiply or divide the inequality by a negative number. Also, if we have an inequality a is greater than b And again, C is a negative number, C is less than 0, then AC is less than BC, and A over C is less than B over C. Take note of our inequality sign. From greater than, it becomes less than. In words, when we multiply or divide an inequality by a negative number, the inequality sign reverses. Let us solve now some examples. This is example 1. Solve the inequality, graph the solution on the number line, and write the solution in interval notation. The first example, 9y is less than 54. In here, we want to make the coefficient of y to be 1, so let us divide the inequality by the coefficient of y. We will divide by 9. And then we can cancel the coefficient and the divisor 9. We will get now y is less than, the quotient 54 over 9 is 6. So our answer is y is less than 6. For our graph, first we're going to draw the number line, and we will put the number 6 anywhere on the line. Our inequality says here y is less than 6. So it means all numbers less than 6 are those numbers that are on the left of this number 6. So this is our arrow. And since the number 6 is not part of the solution, we put a hole on top of the number 6. So this is now our graph. For the interval notation, all the numbers on the left are coming from the negative infinity. So we put first the negative infinity. Of course, we use the parentheses every time there is infinity involved. And then comma, followed by the end number, and that is the 6. And the right parenthesis here means this number 6 is not part of the solution set. So this is now our final answer. Let's have example 2. Negative 7x is less than or equal to negative 70. Again, we want to make the coefficient of x equal to 1. So we will divide the inequality by negative 7, the coefficient of x. But since we are dividing the inequality by a negative number, take note that our inequality sign reverses. So here we have now negative 7x over negative 7 is greater than or equal to negative 70 over negative 7. So after we cancel, only the x comes down, and greater than or equal to negative 70 divided by negative 7 is positive 10. So this is now our inequality answer. For our graph, we draw the number line, and then let us check again our inequality. X is greater or equal to 10. All numbers greater than 10 or equal to 10 are those numbers from 10 and numbers on the right of 10. So this is now our graph. And since 10 is part of our solution, we put a solid dot on top of the 10. For the interval notation, we're going to write all the solution set. It starts with 10. We use the square bracket here to denote that 10 is part of the solution, and then comma. In here we use infinity because the numbers on the right are unlimited. And then the close parenthesis here, because every time there is infinity, we use parentheses. So this is our final answer. Let us have example 3. 9p plus 4 times the quantity p minus 14 is greater than 8p minus 46. So we're going to simplify this using properties of inequality. Let us simplify both sides of the inequality. On the right side, it is already simplified. On the left, we're going to do some simplification. Let us begin by simplifying this 4 times the binomial p minus 14. We will multiply this 4 to each term of the binomial. So we have now this 9p copied here, plus 4 times p is 4p, and then 4 times negative 14 is negative 56. Then we will just copy the right side. Next in line is to combine the 9p plus 4p. It's now 13p. Then the negative 56 is copied here. Then all the right side is simply copied. Next, we are going to remove this negative 56 here. So I'm going to add 56 on the left side. The same value I should add on the right side. So we can now cancel this negative 56 and positive 56. Only the 13p comes down here, greater than the 8p is copied. Then we will combine the negative 46 plus 56. So this is plus 10. Next, the 8p, we want to remove this on the right side. So I'm going to put negative 8p here to cancel this 8p later. Of course, I should not forget on the left side, I should also put negative 8p. Then I can now cancel this 8p minus 8p. This positive 10 comes down here. Then simplifying the 13p minus 8p is 5p. We want to make the coefficient of p equal to 1. We will divide by the coefficient 5. So 5p over 5 is greater than 10 over 5. We can cancel the coefficient and the divisor. Only p comes down here, and greater than 10 divided by 5 is 2. So our answer is p is greater than 2. For our graph, we draw the number line and we put the number 2. Then let us check again our inequality. All numbers that are greater than 2. So those numbers that are on the right of 2. So this is our graph. But since the number 2 is not part of the solution, we should put a hole on top of 2. For the interval notation, we wrote all the solution set. We put the first number 2 as the lowest, but I should write here the parenthesis because 2 is not part of the solution. And all numbers on the right are represented by this infinity followed by the parenthesis. We know that parenthesis is used for the infinity. So this is our final answer. Let's have example 4. Negative 3 is less than or equal to the binomial 4 minus 7x and is less than 18. This problem is a double inequality problem. So to solve this, we're going to simplify the inequality into this form, which means we want to make the middle term to be simplified into x only. All the other variables or numbers must be removed. Going to our problem here, the middle portion is 4 minus 7x. First, I want to remove this number 4 by simply subtracting 4, and since I subtract 4 in the middle part, I should do the same on the left side. There is negative 4 also, that I should do also on the right side. The negative 4 is here. Next, I can now cancel the 4 minus 4. In the middle, it's now only negative 7x. On the left side, I will combine the negative 3 and the negative 4 to be negative 7. On the right side, 18 minus 4 is 14. In the middle portion, it is negative 7x. But again, I want the middle portion to be simplified into an x. I will divide this by the coefficient of x, which is a negative 7. But we know that for the inequality, if I divide by a negative number, the inequality sign reverses. So negative 7x divided by negative 7, look at the sign here. It becomes greater or equal. In the sign here, from less than, it becomes more than. Now we can cancel the coefficient of x and the negative 7 as divisor. Only x comes down. On the left side, negative 7 divided by negative 7 is positive 1. On this right side, 14 divided by negative 7 is negative 2. So our double inequality here now is 1 is greater than or equal to x, and x is greater than negative 2. But let us rearrange the inequality to standard form, which means the lower number comes first. So this negative 2, I'm going to write here first. But when we do the rearrangement, make sure that the inequality is also on proper arrangement. So in here, the negative 2 comes first. The greater than sign becomes less than, and then the x is here, followed by the sign less than or equal to. From this inequality sign, it becomes like this, and followed by this number 1. So this is now our inequality solution. For the graph, we will draw our number line and put the numbers negative 2 and the positive 1 on the number line. We make sure that the lower number is on the left side. Negative 2 is lower, so it is here on the left, and 1 is on the right. And then we're going to connect the two numbers, but the negative 2 is not part of the solution, so we put a hole on top of it. The number 1 is part of the solution because of that less than or equal sign. So we put a solid dot on top of the 1. So this is now the graph. For the interval notation, we put our end numbers, the negative 2 and 1. For the negative 2, we put parentheses because the negative 2 is not part of the solution. For the 1, we use the square bracket because 1 is part of the solution. So this is now our final answer. Hi everyone. Today we're going to learn how to solve applications involving linear inequalities. There are phrases that indicate inequality. For greater than, you will see these words: is greater than, is more than, is larger than, exceeds. For the inequality greater than or equal, you will see these words: is greater than or equal to, is at least, is no less than, is the minimum. For less than, the phrases are is less than, is smaller than, has fewer than, is lower than. For the inequality less than or equal, the phrases will be is less than or equal to, is at most, is no more than, is the maximum. These are now the steps on how to solve applications involving linear inequalities. Step 1. Read the problem and identify what is required. Step 2. Represent the required by a variable and translate the condition into an inequality. Step 3. Solve the inequality. Step 4. Check the answer in the problem and make sure it makes sense. Let's start with example 1. Translate and solve, then graph the solution on the number line and write the solution in interval notation. The phrase is 27 less than x is at least 48. The x we will write first. The word less than denotes minus, and the 27 words is now written as a number. It's here. The word at least is greater than or equal to, and that number 48. So we will solve for x using properties of inequality. We want to make this x alone on the left side of the inequality. We want to remove this negative 27. So what we will do, we're going to add 27 to the inequality. It means to the left side and to the right. So the negative 27 and the plus 27 will become 0. Only the x comes down here. So greater than or equal to, the sum of 48 and 27 is 75. So our answer is x is greater than or equal to 75. For our graph, we're going to write the number line, put the 75 on the graph, and check again our inequality. The inequality suggests all numbers greater than or equal to 75. So our solution set from 75 itself and all numbers greater than the 75. So it will be like this. All the numbers on the number line that are on the right of 75. And that includes that 75. For the interval notation, we will put the solution set. Our lowest number is the 75. All the numbers greater than 75 is now represented by the infinity. For the 75, we use this square bracket to denote that 75 is part of the solution because of that symbol greater or equal to. And the parentheses for the infinity, because as a rule, we put parentheses if there is infinity involved. So this is our final answer. Let us have example 2. Aliyah has $25 to spend on juice boxes on her son's preschool picnic. Each pack of juice boxes cost $2. What is the maximum number of packs she can buy? In step 1, we're going to read the problem and identify what is required. So in here, we want to know the maximum number of packs. In step 2, we will represent the required by a variable and translate the condition into an inequality. We let n be the number of packs. Now, given that $2 times the number of packs is less than or equal to $25. This is the money of Aliyah. So we will write 2 times the n is less than or equal to 25. We will solve now the inequality, and that is our step 3. In solving, we would want to make n having coefficient of 1. So what we will do, we will divide this inequality by the coefficient of n, and that is 2. So now it becomes 2n over 2 is less than or equal to 25 over 2. And we can cancel the coefficient and the divisor. So the n is less than or equal to 12.5. We will check the answer in the problem and make sure it makes sense. But the n must be a whole number of packs. So we will round this number into 12. It means to say, Aliyah can buy a maximum of 12 packs, because this 12 times 2 will give $24. And this is our final answer. Let's have example 3. Michelangelo is planning a 6-day summer vacation trip. He has $800 in savings, and he earns $10 by selling one painting. The trip will cost him $510 for airfare, $700 for food and sightseeing, and $200 for the hotel. How many paintings must he sell to have enough money to pay for the trip? We will go for our step 1. Make sure that we understand the problem and identify what is required. So we want to know the number of paintings. Step 2, we will represent the required by a variable and translate the condition into an inequality. We let n be equal to the number of paintings. Now in here, the total expenses is less than or equal to the sum of the savings plus the income from selling paintings. So putting all the expenses here, the 510 plus the 700 plus the 200 is less than or equal to the savings 800 plus the income 10 times n. We will solve now the inequality. First, let us simplify the left side. The sum of these three numbers will be 1,410. And we will just copy the inequality, also our right side members. Next, we want the 10n to be alone on this side. We want to remove the 800. So we will subtract 800 on the right side. The same value we will subtract on the left side. So this 800 minus 800 becomes 0. the 10n comes down on the next step. We will find the difference of the two numbers. It becomes 610. Then we want to make the coefficient of n equal to 1. We will divide this inequality by the coefficient of n, which is 10. So here it is now 10n over 10, and the left side also is 610 divided by 10. We cancel now the coefficient and the divisor. We have now the n. The left side now is simplified into 61. So our inequality is 61 is less than or equal to n. We want to make this n be on the left side and the 61 on the right side. If we put the n first, look at the sign now. The less than or equal to becomes greater than or equal to. And then the 61 is now on the right side. We will check the answer if it is correct. If Michelangelo will sell 61 paintings, 61 times 10 is 610, plus the savings 800, he will have this 1,410 to cover the trip expenses. So Michelangelo must sell at least 61 paintings. This is our final answer. Problem 1. Graph each inequality on the number line and write in interval notation. Let's have expression A. -2 less than x less than 0. Putting this in number line, we write the number line. Then we locate the 2 points. -2 is on the left, 0 on the right. Then we write whole on top of -2 and whole on top of 0. Then we connect with the line segment. So this is the representation of this inequality on the number line. On the interval notation, we write -2, the first number, comma, and followed by 0. Because of the holes on top of each number, we write here parentheses. Expression B. -5 less than or equal to x less than -3. On the number line, we locate the two numbers, -5 on the left side, -3 on the right. Then we put a solid dot on top of -5 and hole for the -3. This is a solid dot because of this less than or equal sign. We put a hole only for the less than symbol. Then we connect with the line segment. This is now representation by the number line. For the interval notation, we put the two numbers, -5, -3. Because of the solid dot, for the -5, we write a square bracket. For the -3, because of that hole, we put here a closed parenthesis. Problem 2. Solve each inequality, graph the solution on the number line, and write the solution in interval notation. Letter A. 8x more than 72. Here we want to isolate the x. We divide this equation by +8. By doing that, it becomes like this. There is no change in the direction of the inequality. So 8x divided by 8 will be x more than 72 divided by 8, and that is 9. This is our solution. Let's write this on the number line. We write the number line, we locate the 9, we can put in the middle, and this is x more than 9. We're referring to those numbers more than 9. In this case, we put a hole on top of 9 and we connect by an arrow pointing to the right. Those numbers bigger than 9. And for the interval notation, we write like this, which starts with a 9. This is an open parenthesis because of a hole. And on the right side, those numbers that goes to infinity. That's why we see here infinity, and this is enclosed by a parenthesis. For every infinity, we are using a parenthesis. Expression B, negative 5k less than or equal to 20. Let us isolate k. We divide this inequality by a negative 5. But we know the rule. If an inequality is divided by a negative value, we reverse the inequality. So it becomes like this. The negative 5k divided by negative 5, now more than or equal to 20 divided by negative 5. We simplify both sides now. The left side is k more than or equal to negative 4. This is the solution. Now for the number line, we put the negative 4 somewhere in the middle. This is k more than or equal to negative 4. These are the numbers that are equal or more than negative 4. For the interval notation, we write like this. It starts with negative 4, comma, and then those numbers that goes to infinity. So we write here infinity. For the negative 4, because of the solid dot, we write here the square bracket. Again, for the infinity, we use a parenthesis. Problem 3. Solve each inequality, graph the solution on the number line, and write the solution in interval notation. Letter A. 8m minus 2 times the quantity 3 minus m, more than or equal to 2 times the quantity m plus 7, then plus 3m. Let us simplify both sides. This negative 2 we multiply to number 3 and to the negative m. So we copy this 8m. Negative 2 times 3 is negative 6. Negative 2 times negative m, positive 2m. More than or equal to, on the right side, 2 times m is 2m. 2 times positive 7, positive 14. Then we copy plus 3m. Let us now simplify both sides. 8m plus 2m is 10m minus 6, more than or equal to 2m plus 3m, that is 5m, plus 14. Let us now put all variables on the left side and all numbers on the right. So 10m, this 5m becomes negative 5m to the left. This negative 6 we transpose to the right becomes positive 6. Then we simplify now both sides. 10m minus 5m is 5m, more than or equal to 14 plus 6, that is 20. We want the m. We divide this inequality now by 5, that is positive. So m is more than or equal to 20 over 5, or m is more than or equal to 4. This is the solution. For the number line, we write the 4 in the middle, and then we represent those numbers equal to 4 and more than 4. So this is the representation. Now for the interval notation, it becomes like this. It starts with the number 4 going to the positive infinity. For the number 4, we use the square bracket because of the solid dot. For the infinity, always we use the parenthesis. Then expression B. 4k minus the quantity k minus 2, more than or equal to 7k minus 26. Let us now simplify the left side. Let us remove the grouping symbol, but this is a minus in the front. So we know that we need to change all the signs of the terms inside the grouping symbol. So 4k, this k here becomes negative k, the negative 2 becomes positive 2. Then we copy this inequality, also the right side members. Let us now simplify the left side. 4k minus k is 3k plus 2. Let us now put together those variables and all those numbers together separately. So the 7k we transpose to the left becomes negative 7k. This positive 2 transposed to the right becomes negative 2. Let us now simplify. 3k minus 7k, negative 4k, more than or equal to negative 26 minus 2 is negative 28. We want this k value, so let us divide this inequality by the coefficient of k, which is a negative 4. We know that dividing by a negative value, the inequality must be reversed. So, negative 4k over negative 4, now less than or equal to negative 28 over negative 4. The left side now is simplified into k, less than or equal to 7 on the right side. This is our solution. And for the number line, we locate number 7 somewhere in between, then less than or equal to this number 7. We put a solid dot on top of 7, then we put an arrow that points to the left side. Now for the interval notation, the numbers on the left side are represented here by negative infinity, comma, and the last value is 7. When we have infinity, we use a parenthesis. For the number 7, because of the solid dot, we put here a square bracket. Problem 4. Solve each inequality, graph the solution on the number line, and write the solution in interval notation. Letter A. Negative 6 less than or equal to 4x minus 2 less than negative 2. Here we call this a double inequality. That means we have here three parts: the left side, the middle part, and the right side. Our purpose here is to isolate the x in the middle part. Let's begin with this negative 2. We transpose this to the right side and to the left side. By transposing, this negative 2 becomes positive 2. So it becomes like this. The left side is now negative 6 plus 2. In the middle, we have now this 4x, and on the right side, negative 2 plus 2. Let us now simplify the left side and the right side. So the left side now is negative 4, and the right side is 0. In the middle, still the 4x is there. Again, we want this x to be isolated. This time, we divide this inequality by the coefficient of x, which is 4. If we do that, it becomes negative 4 over 4 less than or equal to 4x over 4 less than 0 over 4. Let us now simplify. The middle part becomes x. The left side becomes negative 1, and the right side is 0. This is now our solution. For the number line, we put the two numbers negative 1 and 0 on the number line. And then we show it like this. Because of the less than or equal with the negative 1, we put a solid dot. For this less than symbol with 0, we put a hole, and then we connect them with a line segment. This is now the answer for the number line. Now for the interval notation. We put this negative 1, comma, and 0. Then for this negative 1, because of this solid dot, we put a square bracket. For the 0, because this is a hole, we put a parenthesis. Letter B. Negative 1 is less than 3x plus 2 is less than 8. We transpose the positive 2 to the right side and to the left side. So the middle becomes 3x. On the left side, we have now negative 1 minus 2. For the right side, 8 minus 2. Let us now simplify. The left side is negative 3. The right side is positive 6. Again, we want this x to be alone. So we divide this by the coefficient of x, which is 3. So it becomes like this. Let us now simplify. The middle value becomes x. This left side is now negative 1. And the right side is positive 2. This is now the solution. For the number line, we put this negative 1 and positive 2. Then we show like this. Because of this less than, we put it a hole, also a hole in here. Then we connect by a line segment. For the interval notation, we write the two numbers starting with negative 1, 2. Since both are having holes on this, we put parentheses. Problem 5. Translate and solve. Then graph the solution on the number line and write the solution in interval notation. And the expression is here. 15 less than a is at least 7. Let's begin with this 15 less than a. This means a minus 15. Next is this word, at least 7. This means equal to 7 or more than 7. So we use this inequality, more than or equal to 7. Now let us solve for a. This negative 15 we transpose to the right, becomes positive 15. And 7 plus 15 is 22. This is now the solution. A is more than or equal to 22. With the number line, we show this 22 somewhere in the middle, and those numbers equal or more than 22. So we put a solid dot on top of 22 and this arrow that points to the right. For our interval notation, it starts with 22, comma, and those numbers going to the right infinitely are now represented by this infinity symbol. For the number 22, because of the solid dot, we put here square bracket. For infinity, always we put parentheses.